Look at this diagram. This is a container. This is a container in which I have taken hypotonic solution, less concentrated solution. Clear? Where the water potential will be more. And this is an inverted thistle funnel and the mouth of which is closed with the help of a semi-permeable membrane like egg membrane, clear, or any other membrane of such kind which is semi-permeable in nature. And then in this thistle funnel, clear, some part of this thistle funnel is filled with hypertonic solution. Clear? So, the solution inside the thistle funnel is hypertonic in nature and the solution outside the thistle funnel, that is in the beaker, is hypotonic in nature, and thus the two solutions are separated by means of a semi-permeable membrane. Clear? Now, when you place this experimental setup in an ideal condition, then what do you expect? There will be osmosis, and in the process of osmosis, the water molecule will move from the outer hypotonic solution to inner hypertonic solution. Clear? Because the water potential or osmotic potential of the water molecule in the outer medium is greater than the water potential, clear, of the solution inside the thistle funnel. Okay. So, there will be continuous inflow or of water or endosmosis. In the process of endosmosis, water will enter from outer medium to inner medium, and this inward movement or inflow of a water molecule by the process of osmosis can be observed by the slow rise of this piston through the neck of the thistle funnel. Is not it? When there will be increase in the volume of the content inside the thistle funnel, clear, the column of the water or the solution inside the thistle funnel will rise, and that will push the piston in upward direction. Slowly this piston will move in upward direction. Okay. Now, we start placing the weight, small weight here, clear, in the platform fitted at the upper portion of this piston, slowly, clear, 1 gram, 2 gram, 3 gram, like that, clear. Now, initially when we put small weight, then also we find that there is slow rise of piston in upward direction, clear. Why? Due to osmotic pressure. The osmotic pressure is pushing the piston in upward direction. So, when we slowly increase the weight on the platform of this piston, we will reach to a state when we find that the upward movement of the piston will stop. Clear? Now, suppose here we have put 5 gram of weight. Clear? So, what will be the force due to 5 gram weight? 5 GF force? Yes or no? The force due to 5 gram of mass will be 5 GF. Alright. So, this is the force, or this is the pressure rather, which is preventing the further intake of water in the process of osmosis. So, initially when there was no weight on the platform of this piston, there was gradual rise of this piston, clear, through the neck or limb of the thistle funnel, as there was continuous inflow of water from outer hypotonic to inner hypertonic solution by the process of osmosis. So, that means osmotic pressure was working, clear, for the movement of the water from outer medium to inner medium, clear, and due to this osmotic pressure, the piston is pushed in upward direction, clear, and then this upward movement or upward pushing of the piston is prevented by putting sufficient amount of force in the form of the small weight placed on the platform of the piston. Clear? And we put such an amount or such a quantity of the weight here so that it can just prevent the upward movement of a piston. Clear? So, if this suppose the weight placed here on the platform of this piston is 5 gram, clear? So, the thrust or the pressure exerted by this piston by this piston is 5 GF. Clear? So, this is how we can measure the osmotic pressure. So, osmotic pressure can be defined as the minimum pressure applied by a solution which can just prevent the process of osmosis. Clear? So, definitely this pressure, clear, which is applied by the solution is not by this solution, but definitely by this solution, because this solution is only receiving water molecule. So, this only can apply a reverse pressure, so that a further flow of water will stop. So, osmotic pressure can be defined as the minimum pressure applied by a solution which can just prevent the process of osmosis.